All right, we are starting off with multiplying imaginary numbers together. Remember that when you take the square root of -1, that is going to get you I. So if I took the I, which is the square root of -1, and I squared it, that is the same thing as I times I, or the square root of -1 times the square root of -1, or the square root of -1 squared. What is going to happen when you square a square root? They cancel, it gets you -1. Okay, so in other words, I squared, an imaginary number, when you square it, it gets you -1. That is something you need to know. It's pretty handy in a lot of things we're doing today. That is why imaginary numbers look like they are not there, and then all of a sudden they appear. It's because you had that happening. When you square an I, it gets you -1. All right, let's just multiply. -3i times 7i. We take the real parts and multiply them together. Get you -21. And then you take I times I, which would get you I squared. When I see I squared, we want to replace it. You don't ever want to leave I squared in your answer, because what can I put in place of I squared? -1. -21 times -1. Oh yeah, my answer is positive 21. Okay, try letter B real fast. We take 2 times -5, get -10. Thumbs up if your final answer is positive. Thumbs down if your final answer is negative. It's positive because it's -10 times -1, because that's what I squared is. It gets me 10. Great. 3 plus 2i times 4 minus 3i. It is set up for us to FOIL. You got two binomials being multiplied together, so we're going to FOIL that thing. So 3 times 4 is 12. 3 times -3i is -9i. Then I'm going to take the 2i and multiply by both things. So 2i times 4 would be 8i. And then 2i times -3i is -6i squared. Combine like terms. So I get 12 minus I. -6i squared. What can I replace -6i squared with? That's positive 6, because it's -6 times -1. Oh yeah, that's positive 6. Then I can combine the two things with like terms now, which is 12 and 6, which would get me 18 minus I. Notice that we put the real part of a complex number first. This is complex because as a real and an imaginary part, we put the 18 first and then the minus I. Try letter D, FOIL that out, see what you get. Show me with your fingers. What'd you get for letter D? We're getting a lot of 5s. Let's see if we agree. 2 times 2 is 4. Minus 2i plus 2i. And then I and a negative I would get me -I squared. Okay. These two things are, oh, probably shouldn't do that. Let's try that again. These two things are opposite, so they're going to cancel. That's 4 plus 1 because it's minus -1, because that's what I squared is. That gets me 5. Okay. Again, when we look like this, it looks pretty ugly, but when we multiply them together, we get back to real numbers, which is going to be an important aspect of what we're doing. All right. I'm glad that I could give you a note paper with 2 unicorns that look like they're dancing, and no one questions that. I appreciate that. I appreciate you just trust the system here, trust the process and what we're doing. All right. So imaginary and complex numbers. This is really important. Complex zeros always come in pairs of conjugates. Okay. They always come in pairs. You will never see a single imaginary number by itself. Okay. It always comes with its buddy, its conjugate. Just like, has anyone seen just a single unicorn in the forest? No, they are not by themselves. Okay. No one's ever seen just one. They always come together. Same thing as imaginary complex numbers. This is very important. All right. So for example, if you have a 0 that is 1 plus 2i, its conjugate is also going to be an answer to your solution, or an answer to your equation. Okay, so if 1 plus 2i is a 0, then its conjugate is a 0. To make a conjugate, all you do is change the sign in front of the complex part. All right, so if it's 1 plus 2i, then its buddy 1 minus 2i is also going to be a 0. If negative 3i is a 0, what else is going to be a 0? Positive 3i. Negative 3i goes with positive 3i. Negative 10 plus 5i. It's conjugate. Tell your neighbor, what's your conjugate going to be? Negative 10 minus 5i. I could overhear the crowd saying. Good. We changed the plus to a minus. If 3 is a 0, then what else is a 0? We don't know. We don't know. Because 3 is a real number. Real numbers can come by themselves. Imaginary numbers, we can't. Okay? So that's where we have to understand that distinction between the two. All right, so now we're going to deal with imaginary numbers and understand what's going on with that. There is a method to multiplying. Okay? It is called sums and products. It seems kind of fancy. Let me quickly remind you this. So if you don't have to write anything down, but x plus 2 times x minus 3. If you were to FOIL this out, you would get x squared minus 3x plus 2x minus 6. X squared minus x minus 6. Everybody agree with me on FOILing? To do that, there is a really simple way of FOILing that if it's just this easy. Okay? The x and the x is obviously going to get you x squared. Then we do sums. We add them up. If you take 2 plus negative 3, what are you going to get? Negative 1x. And if you just multiply the two numbers, 2 and negative 3, that gets you negative 6. Okay? This method is called sums and products. It's really easy to FOIL that way. So for example, if I gave you like x plus 5 and x minus 4, or x plus 4 apparently, because I'm writing a plus sign, the answer would be x squared plus blank x plus 20. What number would go here? 9. You would add 5 and 4 together, you get 9. You multiply 5 and 4, you get 20. That's a 4. That's totally a 4. Get out of here. Does that make sense how sums and products works? That's the process we're going to do. Okay? So let's say you had zeros of 3 minus 2i and 3 plus 2i. You would write the factors like this. X minus 3 minus 2i and x minus 3 plus 2i. Super yucky. If I asked you to FOIL that together, you could. Please, please don't do this. But let me show you. Okay? If I were to FOIL this out, I would do x times x. I'd get x squared minus 3x plus 2ix. And then I would take the next number and go negative 3 times x. And then negative 3 times negative 3 would be plus 9. And then negative 3 times 2i would be negative 6i. And then you would take the last number and you multiply it in. Ooh. Plus 6i. Negative 2ix. Sorry, thank you. And then negative 2i times 2i would be negative 4i squared. It's a lot of stuff. There's definitely places you could make a mistake. You combine like terms, so I've got an x squared. Minus 3x, so minus 6x. Plus 2ix minus 2ix, those two things are going to cancel. I got a negative 6i and a plus 6i, those two things are going to cancel. And then I've got 9 minus 4i squared, that's like 9 plus 4, oh yeah, that gets me 13. You can do that. If you would like to, you could FOIL it all out and get it that way. That perfectly works. Definitely not your favorite thing to do. Okay? So instead, a method to FOIL these things together is called sums and products. Okay? So if I wanted to multiply these two things together, the first thing I would recognize is, hey, I'm going to take x times x. That's going to get me x squared. Okay? This is what you should actually do. Okay? X squared. Then we are going to do sums. What does sum mean? Add. So I'm going to add the real parts with the real parts and the imaginary parts with the imaginary parts. So I'm going to take negative 3 plus negative 3. What's negative 3 and negative 3 going to give me? Negative 6. And then I'm going to add the imaginary parts together. Negative 2i and a positive 2i. What's going to happen when I put them together? They cancel. They're complex numbers. They're conjugates of each other. They're going to cancel. To me, they're always going to cancel. But that reminds me, oh yeah, this is the middle part of my polynomial when I FOIL this together. So it's going to include an x with it. Okay, so negative 6x. Then we're doing products. We're taking the imaginary numbers and the real numbers and multiplying them with each other. So I'm going to take negative 3 times negative 3. What's negative 3 times negative 3? 9. This is the product step. And then I'm going to take negative 2i times a positive 2i, negative 4i squared. Okay, that was sums and products. Now all we have to do is just do a quick simplifying. This is x squared minus 6x. This is 9 plus 4 because it's minus 4i squared. So that gets me 13. Same answer. You can FOIL it all out. If that makes you feel better inside, do it. Okay, but using sums and products makes it a lot easier. We add the real parts and add the imaginary parts. Then we multiply the real parts and multiply the imaginary parts and simplify from there. Questions? All right, let's do example 2. Example 2, we are making a degree 2 polynomial with the zeros negative 1 plus 3i. Okay, we're going to create a polynomial. So first thing we're going to do is write some factors. It's degree 2, so I know I need 2 separate factors. Okay, careful with this. Remember, when we write factors, it's always x minus the factor. So if it's x minus negative 1 plus 3i, it's really going to be x plus 1 plus 3i. There's 1. And technically you would distribute the negative, but it's not going to really matter because we're dealing with conjugates. And what's the other 0 going to be? Because if this is a root, so is this one. It's conjugate, buddy. Notice that the sign in front of the 1 didn't change. They're both plus 1, okay? Because this is both negative 1 here. The change is one of them is negative 3i and one of them is positive 3i. That's setting up my factors. Once I've set up my factors, now I'm going to FOIL that together. You could FOIL the long way, or you could use sums and products. I'm going to use sums and products. Okay, so I'm doing sums first. So I'm going to add the real parts together. Okay, so Brooklyn, what's it going to look like when I add the real parts together? 2, because I get plus 1 and another plus 1, so she's going to get plus 2. What's going to happen when you add the imaginary parts together here? The 3i and the negative 3i. They cancel each other out, and that reminds me that when I'm writing this out, x squared plus 2x. That's my x term. Okay, think about that. Hey, this is the middle term of my polynomial. It's going to be a linear term with an x in it. Okay, that's the sums part. We did sums. We added them together. Now we're going to do products. So if we're thinking products, we're multiplying. So if I'm doing products, Alexis, I'm taking the real parts and multiplying them together. So I'm taking 1 times 1. What's that going to give me? 1. And then I'm going to multiply my imaginary parts together. What is that going to get me? Perfect. Negative 9i squared. And she said, oh yeah, if it's negative 9i squared, that's really just plus 9. And so her final answer is going to be x squared plus 2x plus 10. That looks like such a normal quadratic. You would look at it and be like, oh yeah, x squared plus 2x plus 10. That seems so simple. But when you solve it, it got us some really ugly factors. And the reason for that is because when we multiply imaginaries together, they become a real number. Questions on 2? Let's set up 3, and then I'll let you try it. Okay, so we're going to do roots. X minus 1, that's a root. Write your other 2 factors here. Talk with your neighbor. Write what your other 2 factors are going to be. All right, let's write our other 2 factors here. So, Sam, what'd you write for your other factor? I got x minus 1, yep. And then what else? Good, x minus 2 minus I. And I would always suggest you write the other root up here, because otherwise sometimes your brain plays tricks. So if 2 minus I is a root, Sam, what was the other root going to be? Yeah, 2 plus I, so it's going to be minus 2 plus I. Good. Just writing it out, because otherwise sometimes you'll change the thing in front of the 2. Don't do that. Okay, there's that setup. If I want you to FOIL this out, deal with this one last. Okay, x minus 1 multiplying in, that's really easy. You don't want to try to make this uglier than you should. Start by FOILing conjugates together. Okay, anytime you have conjugates, put those together because things are going to cancel out and make things easier. Then multiply in the x minus 1. Okay, so with your neighbor for a second, do sums and products with that thing right there, and then multiply in x plus 1. See what you can do. Go. Let's do it. So we're going to start off by doing sums and products. X times x is going to get me x squared. Brooke, what's your sums step going to be then? We're adding. So if we're adding them, it's going to be -2 plus -2, which is going to get me, good, -4. And my imaginary numbers are going to cancel, and that reminds her to put x. Good. Sums. 2, -2 plus -2. We're adding those together, gets us -4. And then the i's and the negative i's, those are going to cancel. Okay. Then we're doing products. Ben, if we're doing products here, what's that going to get us here? Plus 4. We're taking -2 times -2. That's going to get me a plus 4. What about negative I times I? That's negative I squared. I'm sorry. I don't know why I wrote that like that. Don't do that. Sorry. We're putting those separate. It's 4 and then minus I squared. Sorry. Negative I times I. Great. Then we're going to simplify that thing. So I'm going to get x squared minus 4x. And then, Ben, what are you going to end up with there? Plus 5, because it's 4 minus a -1. That's 4 plus 1. That gets me plus 5. Okay, that is the original one. If you don't want to memorize sums and products, you can FOIL that thing. Okay, every year I always have a student that FOILs it together. There's just a lot of mistakes you could make. Okay, sums and products makes it a little bit easier. Once I've done that, now I'm multiplying in the x minus 1. You can do this. I'm very confident in your abilities. You're getting x, sorry, I'm running out of space, x cubed minus 4x squared plus 5x. And then I stole this from a student a few years ago that I liked how she kept her paper organized here. -1 times x squared. She put that underneath the x squared column to try to make things a little bit simpler here instead of just drawing one long line. Plus 4x. And then minus 5. And so now if they're stacked like that, if we stack up things, it's a little bit easier to add up. I got an x cubed minus 5x squared plus 9x minus 5. That is my final answer here. So we know that polynomial is going to have 3 answers. We just didn't know that 2 of them are going to be pretty ugly. All right, let's go with backside. Example 4. So now we're back to what we learned on Friday. Find the remaining zeros of the polynomial given this polynomial, knowing that 5i is a 0. How many answers am I going to have here? 3. How many of them are going to be real answers? Tell your neighbor. How many, and explain why. How many real? Show me with your fingers how many of them are going to be real. 1 is real because 2 of them have to be imaginary. 5i is a root. What else has to be a root? -5i, it's conjugate. Okay, so if we know roots, we're going to do exactly what we did on Friday, which is synthetic division. Okay, we're doing 1, 3, 25, and 75. Box and a line. At first glance, this looks tougher, but in the end, it's going to be really easy. Okay, so don't let this be harder than it is. 5i is going to go in the box. I know what I'm going to get right here. I'm going to get 0 because I know 5i is a root. Then I'm just doing synthetic division. I'm taking the 1, I'm dropping it down. I'm multiplying. 3 plus 5i. Can I add those two things together? No. That's like adding 3 plus 5x. You can't add 3 plus 5x. Those are not like terms. And so I'm going to write 3 plus 5i right there. Okay, I can't combine like terms. Then I'm taking 5i times 3 plus 5i. You can do that. 5i times 3, that would be 15i. And then 5i times 5i. What would 5i times 5i get me? 25i squared. Or what else could I write instead? Minus 25, because I squared is going to make it -1. I'm going to combine like terms. So I can combine the 25 and the -25. Those two things are going to cancel. gets me 15i. And then if we did it right, in the end, I've got 5i and 15i. That'd be 75i squared, or in other words, negative 75. It got me 0 like I wanted. That can seem big and scary at first glance, okay? But you know what you're going to get in the end. It's just a matter of getting there, okay? If you do all your work correctly, you're getting a built-in check. The good news is, oh no, this is a really ugly quadratic. I don't care at all about that quadratic, okay? This was an x cubed. This is an x squared. But if 5i is a root, as soon as you do synthetic division with one imaginary number, you want to jump right in and do synthetic division with its buddy. So if 5i works, negative 5i is going to work. Drop the 1. Multiply. The 5i and the negative 5i are going to cancel, leaving me with just 3. This time through, there should not be any i's on this bottom row anymore. Because if we took out a pair of conjugates, there's not going to be any i's left. 3 times negative 5i is negative 15i. Good, because I know it's going to work. If the first one's a root, so is the second one. 5i is a root, so is negative 5i. 1 and 3. What does this 1 and 3 represent? Is this x squared plus 3? Just x, because it wasn't x cubed. I took out an answer, it's x squared. I took out another answer, this is x plus 3. So my zeros, my roots, are going to be 5i. Let's write x equals 5i, negative 5i, and negative 3. Questions on that one? Let's do one more. Okay, example 5, a little bit rough here. Find the complex zeros of this polynomial. Write k of x in factored form. I'm going to go ahead and highlight that now. That's the number one mistake made on Thursday's quiz. Okay, writing it in factored form. Mostly kids either don't do it or they forget. I don't know. Okay, or they don't know how. But make sure you don't miss that. So this thing right here, in the end, I'm trying to write it in factored form. I'm trying to write it as a factor. All right. So how am I going to start? They didn't tell me zeros. P's and Q's. Get going with that. See what you can do with it without me holding your hand. See what you got. This one's a mean one. Okay. This would be a handy one to use your graphing calculator. Anybody get us started here? Anybody try 1 or negative 1? Negative 2 sounds like a good number to check. Another good number to check here. 1/3. 1/3. Good luck with that. Let's see what you can do. All right, so my P is 18. I'm doing all the values that multiply together to get me P. So 18, 9, 6, 3, 2, 1. My Q is 3 and 1. So my P's over Q list. Plus or minus 1, 2, 3, 6, 9, 18. And 1/3, 2/3, 6/3 don't need it, 9/3 don't need it, 3/3 don't need it, 18/3 don't need it. Okay, so there's my list. Again, using your graphing calculator, I graphed this on my calculator and saw my 2 zeros. Okay, it's not just as easy as doing that because we're going to have some complex zeros here as well. So that's why we have to do a little bit more. Okay, so I'm going to go in here. Somebody said negative 2 worked, and it did by looking at my graphing calculator. I'm doing synthetic division. I drop my 3. I multiply. I add. I multiply. I add. I multiply. I add. Oh no. Did negative 2 work and I just didn't do it right? Let's try again. That's why it's good to be good with your calculator. I wrote my numbers down wrong. Yeah, let's try that a third time. There we go. Sorry guys. Negative 9, 18, 0. There we go. Math's hard on a Monday. We get 0. Okay, that's a little bit rough. This is a cubic. Again, I used my graphing calculator and found that I also crossed at positive 1/3. And so I'm going to do synthetic division with 1/3. Okay, which seems ugly, but I'm going to know that I'm not going to get weird answers in the end. It's just going to become a little bit cleaner. So I dropped the 3 I multiply. 1/3 times 3 is 1. That gets me 0. 1/3 times 0 is 0. 27. 1/3 of 27 is 9. Oh, okay, good. It got me 0. So it looked really bad. It's not as bad as it seems. Okay, not as bad as it seems. And 3, 0, 27. What does this represent here? 3x squared plus 27. I take that thing and set it equal to 0. Oh, I can subtract 27. I can divide by 3. X squared is -9. So x is going to be equal to plus or minus 3i. So stick with me here at the end here. Okay. We've got this. We didn't do this yet. Write k of x in factored form. Okay. So if I'm writing this in factored form, I'm going to write them as 0. So x minus 2 plus 2. That's what I said. X plus 2. What else do I need? So you can put x minus 1/3, but be very careful if you do that. I would rather you write that as 3x minus 1. Okay, because otherwise, if you don't do that, you're going to have a mistake in the end, because when I FOIL it back together, there should be a leading coefficient of 3. And if you write x minus 1/3, you're not going to get that leading coefficient of 3. So you could make it x minus 1/3, but in the end, you better put a 3 out in front of everything, so you might as well just put it now. 3x minus 1. What else do I need? X minus 3i, x plus 3i. That is in factored form. Again, a big mistake that kids will make here. It's 3x to the fourth. So when I multiply that back together, I better get 3x to the fourth. And I do because of this 3 right here. So just be careful with that 1/3 guy right there. It's a little bit strange. Questions on something we did today?